I hear your voice and I know what you're going to say.
Amazing.
Okay, so let me rearrange my camera. Why isn't my camera working? Not good. Oh, I know. I think I need to. Hold on. I think I need to change cameras. 1 second. Oh, it's not letting me. Ah, there we go. Woo. Okay, that's good. Okay, what is this? What am I seeing? Oh, that's my computer. Move it over a little bit so it's not blocking us. Okay. Settled here. My daughter is coming to visit us next week, so I'm going to have to move my training room here. I've got her whole room set up with all sorts of equipment. There we go. Okay. All righty, so we are going to, I'm actually going to combine the first 2 lessons that we looked at on the handout. Let me just show you again. So I have square root using the stamp game and then the square root with the binomial guide. I'm actually combining these 2 today because it's really repetitive otherwise. Plus, I'm not sure why they separate them out because I really need to use my binomial guide in order to do this problem. So I'm just going to combine those 2. All right, just so you know. Okay, so we're going to be using our binomial guide from yesterday to help us with this problem. And the lesson is called Square Root with Binomial Chart. I've abbreviated, I hope that's okay. Square Root with Binomial Chart. And we're going to be using the stamp game instead of the pegboard, like the album suggests, all right? Okay, and the problem that we're doing today is the square root of 625. And you see that I've already analyzed the radicand starting from so yesterday we said we're going to start from the left. I'm going to have to clarify this, guys, because obviously here we're starting from the right. And I'm not sure, let me just see real quick what they say in here as to why they're doing that. All right, I'm not getting a quick answer, but I will research this for you and have an answer for tomorrow or later today if I have time, because this is clearly an inconsistency, all right? Yesterday, if you remember, when we looked at our radicand that had 6 digits, we started from the left. I think I may have said the wrong thing and we actually do start from the right, but I need to clarify that. So just hold on to that question for a little while. I'll try to get back to you today. I'll look into it maybe when you're practicing. All right. In this case, this is really what we want. So I suspect that I said it wrong yesterday. All right. So for now, let's just assume that we're going to pair from the right. And we come up with, of course, 2 place values. So we know that our square root will have 2 place values. All right. Okay. So we're going to start with first using the stamp game. I'm going to make the radicand. All right. So I need 600s. So I have 2, 4, 600s. All right. Let me move the title here, and I will move this over here. Okay. So we have 600s and 2 10s, 2 10s, and 5 units, or 5 units. Okay. So there we go, 625. All right. Move these up a little bit. And then I'm going to get my square guide because I really want to use that to help me in what I need to do. All right. So we are going to make a square. We're going to build a square that will equal 625. The value of the square will be 625. I'm going to use the binomial guide to help me visualize how we're going to build the square. All right. Now, we know that there's going to be 2 digits in the answer. All right. The square root is going to have tens and units. So we know that we are going to have 2 perfect squares, like we do in our binomial chart, and 2 equal rectangles. All right? Okay, so I'm going to ask myself, again, I'm going to start with the largest place value. We always start with the largest place value, just like we do in division. I'm going to ask myself, out of these 600, what is the largest perfect square that I can make? What is the largest perfect square? Okay, and I'm looking right here at this corner of my binomial guide. Well, I know that the largest square that I can make is right there. Okay. So I've used 4 of my 600s. And I can't, I could certainly do that, but that's not a square, that's a rectangle, right? There's nothing I can do. That is the largest perfect square I can make out of 600. That's it. So I'm finished with this. All right. So I'm going to continue now. I can't do anything with these hundreds. So I need to exchange these for tens so that I can continue to build my square. And the next thing I'm going to try and do is I'm going to build this rectangle and this rectangle. And of course, it'll be built out of tens, yeah? So let me go ahead and exchange this 100 because there's nothing I can do with it. 2, 4, 6, 8, 10. Make sure I have 10, otherwise I'm going to be really unhappy. Okay, and I join it with my other 10s. And now I'm going to exchange this other 100 for 10 tens. Two, four, six. Okay, and then I have all of my tens right there. All right. All right, so now I'm going to start building my rectangles, but I'm going to do it one step at a time. So I'm going to alternate from here to here, here to here. If you remember when we did division, we wouldn't just distribute all of these tens to one skittle, right? When we were doing division, for instance, with the stamp game, we give each skittle one 10 and then make sure everybody has the same amount, and then we move on to the next one. We're going to do the same thing here. I'm going to start building this rectangle right here by placing two tens over here. And now I'm going to say, okay, well, if I do that here, I better do it here because I know that these two rectangles are equal. All right, so I'm going to keep building. Now I can switch back to the side. And switch again.
I have a question, may I?
Yes, of course.
Why wouldn't we build it on the template? So we are sure that we are building the right.
Oh, because it won't always be the same size.
It won't always be, okay.
Yeah, it won't always be the same size. But good question. Okay, I'm going to keep going here. I'm up to 3 rows of 20s. I'm building my 4th row of 20s on one side and my 4th row of 20s on the other side. And my 5th row here. So far my rectangles are equal, which is a good thing. 2, 3, 4, 5. 1, 2, 3, 4, 5. I did something wrong. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Oh, no, I didn't. I'm good. Okay. That's as far as I can go because I only have 2 left. So I couldn't possibly keep the rectangles equal. I would need at least 4 of these, right, to continue distributing. So I'm going to stop. Once again, I need to move now to the units. There's nothing I can do with these 10 stamps, so I need to exchange them for units. So I'm going to go ahead and do that. 2, 4, 6, 8, 10. Please make sure you have them. If you get to the end, 2, 4, 6, 8, 10, you've made a mistake, you're going to really frustrate yourself. All right, now I'm going to exchange my other 10 for 10 units. 5, 8, 10. 2, 4, 6, 8, 10. Okay. So we have now built our 100 square. We've built our 2 rectangles. And now all we have left is our perfect square. So let's go ahead and fill that in and make sure that we have the right amount. Okay. And of course, this will be, it looks like a 5 by 5 square. So I should hopefully have 25 units to complete my square. Are you guys doing this at Prague on the floor, I hope, or not? Did people forget? You forgot? Is that why you're nodding your head? No, you're doing it. Are you on mute? Is that why you're using sign language instead of talking to me? I love when you know, that many of us have been doing remote teaching this last school year. And it's so funny where my kids are when, you know, there's one boy in particular, he's walking around outside. He's carrying his phone on my lesson and walking around in a barn, walking in the woods. I'm like, Jonah, where are you? And then I have other students that they'll hide. They keep the camera off. And I always say to them, please turn on your camera. I need to see you. Make sure you're not sleeping. Okay, so there we go. We've completed our square. If you recall, when we were talking about square roots, we said that to read the answer to a square root problem, we're going to go to the sides, right? This is the square of 36. The square root of 36 is 6. We can get it from here or here. All right. Now we have the square root of 625. We've made a square. So we're going to get our answer by looking here or here. We can't do it from here or here because remember, this is a real square. This is a symbolic square, right? Because to make the real square and be able to read our answer from all 4 sides, we would have to have 625 units, all right? And that would make us all nuts. So this is a symbolic square, which means you're not going to read your answer here. You're going to read your answer on the bottom or on the right. On the bottom or on the right. And of course, my answer is the square root of 625 is equal to 25. 25. So it's right here. 10, 20, 1, 2, 3, 4, 5. Or right here. 10, 20, 1, 2, 3, 4, 5. Okay, and if you guys want to check our work, you can get your calculator and see what the square root of 625 is. And you'll see that it is 25. So we can say that 625 is in fact a perfect square, right? We've made a perfect square. As a follow-up, I'd like you to draw the layout, but I want you to do it in steps. I want you to first draw our first 100 square that we made. Then I want you to draw the 2 rectangles, just like we built it. So I want different drawings. I don't want you to build on your own drawing. I want 3 different drawings that are going to show the 3 steps. So your first drawing will just have this. Your second drawing will have this plus the rectangles. And finally, your third drawing will have the whole thing. And it'd be great to do this on graph paper so that we can represent every stamp with a box, do it in color. And let me see if we have follow-up problems for this. Yes, we do. So we have a bunch of practice problems, which I'm going to, can I share screen or are you guys still? Well, I'll come back to this. Let me quickly share screen. Just want to make sure. Yes, I did put some problems in here. Okay, so here's practice problems. And these are selected so that they are all perfect squares, so you're not going to run into remainders because we haven't given that lesson yet. So when we're ready to practice, do I have people waiting? Let me see. Anybody waiting in the waiting room? No, I don't think so. Okay. All right. So as a follow-up, please go ahead and do these, a few of these practice problems until you're really comfortable. Always draw your layout. Oh, I do have some people, Marguerite and Leah. There we go. All right. Any questions on what we've done? Wow, that was perfectly clear, huh? Good. Okay. Hello, Margarita Maria.
Good morning.
Tell her we were here on time.
Sorry, I'm sorry you missed the lesson. That's going to be critical for us going forward, but try to follow along, okay?
We will. We were here. We just didn't know how to get into you. So
Oh, how long did you wait?
we've been trying to get in since 6:45 our time.
Oh, 6:45.
Yep. No, we didn't know the link. Jerry didn't post it. We didn't realize it was the same one every day. So we were looking.
I'm sorry. I'm sorry.
Oh, that's okay. We'll figure it out.
Yeah, you will. No problem.
What is the name of this lesson?
Okay, so the name of the lesson we just did was Square Root with Binomial Guide,
Okay.
right? And this is the layout.
Yeah.
You know what I'm going to do?
What page is that on the manual?
Page, hold on, let me find it. Page, give me a sec. Page 248. 248.
Is it also Study of the Radican? No, is that different?
No, that's different. Do you have a
Different manual, yeah.
You have the 2013 manual?
Uh-oh. Yes.
Yeah, so it should be page 248. Square root with the binomial guide chart.
No. Oh, I've got it, 251. Okay.
Oh, that's weird. If it's the same edition, I don't understand why. All right.
Okay. And actually, we had this lesson when you were in Jacksonville. So.
Oh, good. Okay, so, all right. So I don't need to take a picture of this for you. You're good?
I'm good.
Oh,
I think we're good. Yeah.
Oh, that's great. Okay. All right, that's good. Okay, so now we are going to move on to the next lesson, which is called Confirmation. Some of these titles are terrible. Confirmation of the square by the last digit. Oh, I hate that title. By the last digit. Let me actually share this for a moment. Hold on, I'm going to share my screen. And I want you to see this, and I want to change it a little bit. All right. So we are right here. Confirmation of the square root by the last digit. All right, we're going to give this a different title, an alternate title. So that's the title that's in the textbook. What I would have called it is square root of a non-perfect square. That's not great either, but it's better. So we just looked at the square root of 625. We said that that was a perfect square. We saw a perfect square. We made it. Well, we're now going to take a look at the square root of 615. Okay, 615. And it's going to become obvious as we do this that we don't have a perfect square. So let me go back to what we have here. All right, so we have confirmation of the last digit, and we have the square root of 615. All right. So I'm I'm going to try very hard not to, let's see, I'm trying to save some time, but let's just, we had 625. I'm going to take away 10. 3, 4, 5, 6, 7, 8, 9. This is not how I would do it with children, please. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right, so I'm just giving you a little background before I start the actual lesson. So you see that if I were to do the same process that I did before, I would lay out my 100 squares, and then I would lay out my rectangles. So far, so good. And then I have my 15 units. And I go and I try to fill in my square, and I realize, whoops, I don't have enough units. I don't have enough units to fill my square. And remember, when we're finding square root, we need to make a perfect square. We can't have anything but a square, all right? Otherwise, you haven't found the square root. How are you gonna read your answer, all right? Okay, so I'm going to fast forward through the lesson with children in the interest of time, and assume that we pulled out 615 stamps like we did before. We first built our 100 square. We had 200s left over. We exchanged them for the 10s. We distribute the 10s to give us 5 and 5 rows of 10s. And then we exchanged the 2 10s that we had left over, if you remember, for units. And no, we won't have, I'm sorry, you won't have any left over, obviously. You won't have any left over. You'll have, well, you know what? We're going to do it because otherwise we're going to get messed up. All right. So let's do this. We've built this, right? I'm just going to have to do it, guys. I'm sorry. There's no other way. Let's just do it. I don't want to confuse you. All right. So let us say we have 615. Okay, 615. I have my binomial chart here. Okay, just like before, what is the greatest square that we can make out of 600? The greatest square we can make is 400. Okay, we have to exchange 100 for 10 10s. 2, 3, 4, 5, 6, 7, 8, 9, 10. Those join my 10s. I need to exchange another 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now I can start building my rectangles. So let's go ahead and start. Okay, I alternate between the two to make sure that the rectangles are equal to each other. We know this from our previous work. The rectangles must be equal to each other. I'm sorry, I did that totally wrong. Right there. You've got to save this space, right? Look at your binomial guide. The rectangles are totally adjacent to the 100 square. We can't be going into the units place. This is why the binomial guide is so critical. It keeps us honest. All right. So here we go. Okay. All right. What is this doing here? 2, 4, 6, 8, 10, 2, 4, 6, 8, 20. Okay, I don't know about this. I think, was this here part of my thing or no? I don't think so. See, I'm getting myself. Okay.
No, I think you needed that.
Yeah, you think so?
Yeah,
All right.
because the
Oh, yeah, of
number
course.
was 615.
Yes, yes. Thank you very much. Okay. So great. So far, so good. Yeah. Now I'm going to exchange my 10 for 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I'm going to build my perfect square, my unit square in the middle. Here we go. And the students at this point are going to be raising their hands, jumping out of their seats, because they already see that you're not going to have enough. Wait, what's going on? What are you guys upset with? You're not going to have enough units because you need 25 and you only have 15. Oh, you are right. So what are we going to do? What does this tell us? Well, it tells us, first of all, that 615 is not a perfect square. That's the first thing it tells us. So what do? How are we going to find the square root if we can't make a perfect square? Well, what this means is that we need to be able to find a way to finish the square, right? So the only way I know how to do this is to take away, so let me just move these out of the way for a minute, okay? I obviously made my rectangles too large. Obviously, if I need more units, then I need to make my rectangles smaller. I made them too large, all right? So I'm going to actually take away one row of each of the rectangles. Make sense? I have no other way of doing it, all right? Okay, so I am going to go ahead and exchange these 10s for units, and then I'm going to start building again, all right? But before I do that, let me just put these back because I know these are going to be there anyway, right? Except I need to rearrange them a bit. This needs to go here because now I have a different square. Okay, so it looks like I'm missing one. I'm going to for now just exchange one of these 10s for 10 units so that I can finish my square. 2, 4, 6, 8, 10. I'm going to go ahead and, all right. So what's happened? Well, I found a way to make a perfect square, but did I use all of my Radicand? No, I didn't use all of my Radicand. What do I have left? What do I have left? Let's see if I did it correctly. Oh, I did, good. So what do I have left? I have 30, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 39 left over. I have 39 left over. So I'm ready to write my answer. Remember, where do we read the answer to a square root problem when we're using the symbolic square? We either read it along the bottom or along the left side, the right side. And my answer then is the square root of 615 is 20, 1, 2, 3, 4. 24. So my answer is 24, but because it's not a perfect square, I have a remainder of 39. And that is how you write it. 24 remainder 39. If you recall, when we did the square root of 625, the answer was 25. Now we only have 24 with a remainder. Remainder 39, we would have needed 4 times, we would have needed, let's see, 5 times 5 is 25. Trying to think how many more beads will we have? We needed 10 more beads. If we'd had 10 more units, we would have been able to make the perfect square of 25, right? But we didn't have the 10 more units. So we had to go back to 24 with a remainder. So we could say that 615 is not a perfect square. It's not a perfect square. And let's just, for yucks, look at 24 and square 24 and see what we get. So I'm going to pull out my calculator. 24 squared is 576. And hopefully if I add 39 to that, I get 615.
But can I have a question?
Of course.
You said that we would need to add 10 more to that 39 to create a square of 615. So wouldn't be adding to that original number 49, not 39?
Right,
I mean,
we would need 49 to get to 25 squared, but we only have 39.
Yes, so when you calculated that on your phone, that would be 24 times 24 plus 49, right?
24 times 24 is equal to 576. Yeah, if I add 49, I get my 625.
Because before you showed 615.
Yeah, because I added 39. I was confirming the remainder, that's all.
Ah, sorry. I thought you were trying to show that
No.
what we need to add to get to another perfect square. Okay, good. Thank you.
You're welcome. Okay. All right, so questions. Okay. So at this point, I have a question. Do you guys want to practice or do you want to continue? I know some of you don't even have materials to practice with, but let's have a show of hands. I think we'll take a 5-minute break anyway, but a show of hands, do you guys want to continue? All right, good. Do you guys who wants to practice? All right, that's good actually, because I have a better place to stop for you to practice. If I can do one more lesson, then that will be a much better place for you guys to practice. All right, so what we're going to do is let's take a 5-minute break, promptly come back at, let's see, it's 49 after the hour. So let's say 55 before the hour, 55 or 5 minutes before the hour. Okay, thank you. All right, guys. Let's come on back. Okay. I'm going to go ahead and get started. All right, so now we are going to start. This next lesson is going to show us how to do the notation for square root. So far, we have just been doing it with materials and writing down the answer. So now we're going to start showing the students the actual notation for the square root. So we're going to do the same problem we did before, which was the 615, to start showing the notation. All right. Situated here. All right. So once again, we have all right. Actually, the title of this lesson is the same as the one before, because actually what they do is in the album, they show you in one lesson, they show you the square root of 615 with notation. And I don't like that. I split it up because I always think about isolating the concept that you're trying to teach. You only want to teach one new idea at a time. What they've done in the album is they're teaching the idea of taking the square root of a non-perfect square and teaching the notation. They're doing both at the same time. I don't think that's a good way to do it. That's why I split it up into two lessons. One is to show the idea that I don't have a perfect square and I have to backtrack. I had to take away some rows of my rectangles in order to complete the square. So that's one lesson, that's one concept. And then the next thing I'm going to show is notation. All right. Okay. Okay, as I look at this more and more, I think that my mistake yesterday was that you really start from the right and not the left. I haven't had time to look at it yet. All right, 615 square root. So guys, you remember we did this before, yeah? Okay, well today we're going to do it the same way as we did before, but I want to show you how you write down all your steps on paper as you do it. All right. All right, so when I analyze my radicand, I see that my answer is going to have 2 digits. The way I show that is I extend this line and I'm going to make a line down here. I'm going to write tens and units. So as I work, I'm going to be recording my answers here, and I'm going to be showing every step down here. All right, it's going to look to you very similar to the division algorithm that we use here in the United States. All right, once again, I need to form my radicand of 615. And there it is. All right. I want to make sure my computer doesn't fall off the table, but I want it off the screen. Okay. All right, so our 615. We're going to start just like we did before by making our largest perfect square that we can out of 600. And that is my 400. Of my 600s, how many have I used? Yep, I've used 4. I'm going to write a 4 under the 6. And subtract 4 from 6 to show that I have 200s left. I used 4 of my 6, I have 200 left. So I'm going to write my 2 right under the 4, just like we do in division. Okay. I now can write my answer to the tens place because I know that it's going to be 2 tens. I know that from here because we have 4. The square root of 4 is 2. So I can write my 2 right there because I know that that's going to be the answer in the tens place. So there I go. I write my 2 right there. As soon as I see it, I write it down. Okay, and that comes, this 2 comes from that 2 right there. All right, just like before, I can't do anything more with these hundreds, so I need to exchange them for tens. So I'm going to go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I exchange the next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I'm going to start building my squares. I mean, my rectangles. All right, I start on one side, I alternate, and forgive me if my tens are upside down and backwards. I guarantee that your upper elementary students aren't going to care unless you've got a child that has OCD tendencies, and then they will care and they'll fix it for you. Okay, I'm going to keep alternating until I use up all my tens. Yeah. I know you guys know that 615 is not a perfect square, and you're yelling at me because you're saying, no, you can't. You're going to have to bring that back. But we're approaching this problem fresh, as if we didn't know that. All right. Okay, I can't go any further. So I'm sorry. So what I'm going to do right now, I'm sorry, I should have done this before. I'm going to bring down the 1. I'm going to bring down the 1, put it right here. Okay, so I exchanged my 200s that were left for 10s, and I was left with 21 10s. 21 10s. I distributed 20, and I have 1 left. So I'm left with 21 10s. I distribute them. Okay, sorry, I forgot to show you that. But you see that, yeah? Okay, so I can't go any further, but at this point, I do know, or I can guess, I don't know yet, but I can guess that my units place is the answer, the root is going to be 5. Okay, so I'm going to write it in a different color. And I'm actually going to write it really funny. I'll show you. I'm going to write it as a dotted 5. You guys could write it in pencil. And why am I doing that? Because I really don't know yet if 5 is going to be the answer in the units place. I don't know that until I confirm it. Okay. So this part of the problem so far is called the live part of the problem, live. I'm going to write that down. This is the live part of the problem. Okay, live. And why is this the live part of the problem? Because everything else from here on in, all the steps from here on in are going to be used to confirm whether 25 is the right answer. All right? If we're, yes?
Just a quick question. Can you repeat why you are guessing or assuming that this 5 is useful somehow? I missed that. I don't.
Okay, so we are using 615, which we already know is not a perfect square. We already know from our previous lesson. So it might even be better to maybe use a different number. So the reason I'm putting the 5 in pencil so I can erase it is because I haven't really confirmed yet that I can make a perfect square out of this, right? We won't know that until we do all our exchanging and putting in our units, all right? So give me a moment through this presentation and I think you'll get your answer, all right? All right, so this is called the live part of the presentation. The rest of it, from here on down, is really just going to be a confirmation. And some people call it the dead part of the, okay, so I'm actually going to write that here. I'm going to say live and dead, or confirmation. So, all right, from here up, it's the live part. From here down, I'm explaining this to you because you're going to see it in your album. I don't necessarily do this with children, but you can. The rest of the calculation is going to be to confirm that the 5 is really real. And once it is real, I'll go ahead and fill it in. All right, so we're going to now continue so we can confirm our perfect square. So I need to exchange my 10 for 10 units. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let me first write on here. I used 20 of the 21 tens, and I am left with 110. So I started out with 21 tens. I used 20 of them, which left me with 1. And then I took that 110 and I exchanged it for 10 units. So I'm going to bring down the 5. I bring down the 5, and there are my 15 units that are sitting right here, ready to be distributed. And right away, your students are going to see from the layout, they're going to see that we have a 5 by 5 square. We need 25 units. There's no way that 15 is going to do it. What that says is that our 5, 1, 2, 3, 4, 5 is too large. And we need to back up. We can't make a perfect square out of this. So we need to back up. All right, so we're going to back up. We are going to take away 1 row from this side, 1 row from this side. All right, and we are going to cross out the 5 in the units place or erase it and put a 4. We're going to cross out the 5 right there and put a 4 because our confirmation didn't work. We need to backtrack. We need to backtrack. Okay, so if we're doing that, then if we're only using 4 rows here, then instead of 20 tens, we're really only using 16, right? 2, 4, 6, 8, 2, 4, 6, 8. So the 20 changes to 16. I cross out my 20 and I put in 16. Of the 21 tens, I didn't use 20 of them. I backtracked and I only used 16 of them. So if I only use 16 of them, then 21 minus 16 is 5. So I changed this from a 1 to a 5. I bring down my 5 just like I did before. I now have 55 units. And you can see that right here. Right, I already exchanged one of the 10s, but if I count, I have 55 units. All right. So now I can start filling in my square. I better go ahead and exchange another 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. Complete my square. So of the 55 units, I used 16 of them. I used 16 of them. Which gives me, well, let me just show. So this 16 is what confirms. The 16 confirms the 4 in the units place. And there's our remainder of 39. So my answer is 24, remainder 39. 24, I wrote it right up here, remainder 39. All right, don't feel like you need to capture this. It is in my, let me actually show you. Let me share my screen. Okay, and here it is. Just make sure it's all here. Yeah, it is. I'm going to put a page break here so it's all together. Okay. Actually, sorry. Let's do this way. And put a page break right there. Let's do it here. All right, so let's walk through this once again just to look at it. All right, so we start out with the square root of 615. And we know our answer is going to be in the tens and units because we analyzed the Eradicand. The largest square we can make out of 600 is 400, right there. I subtract the 4 from the 6. I'm left with 200s. I bring down the 1. I exchange the 200s for 10s. And I use 20 of them to make my 5 rows. Okay, and I'm actually going to add right here. I'm going to add a 5, but we're going to put it in red just to show that it hasn't been confirmed. And when I go ahead and build my rectangles with my 20, I realize very quickly that I'm not going to have enough units to complete the square. So I'm going to start again. I'm going to say, okay, I know my 2 is okay. Okay, right there, 2, 2. But I can't distribute 20 I have to only distribute 16 because I have to back up. I have to shorten my rectangles by 1 row. That leaves me with 5 10s. I bring down my units. I complete my square using up 16 of the 55 units, leaving me with a remainder of 39. Okay, so there it is. Any questions?
I have a question.
Yes.
So when you're doing this and you're moving, I guess you're getting one step closer to abstraction where they could, is the goal to get them to be able to complete this?
Yes. Yeah, that is the goal. That is the goal. We're not going to get there in these sessions together because I just don't have the time. What you do with children is you give them lots and lots and lots of practice, and eventually, by having shown them the algorithm written down, they eventually can see it in their heads and they can do it. Okay, I'm not going to bring you there together. I'm showing you the sort of the beginnings of the lessons, and the rest sort of falls out from that. I think you'll be able to, figure it out. I wanted to give you, what I'm giving you are the sort of the key lessons.
So in your experience, do you get 6th graders to be able to do this abstractly?
Yes, totally.
You do.
Not every 6th grader. Okay, let me make that clear. So I'll give you an example. The year, not this last year, the year before, we had 3 students out of 7 6th graders. So a little less than half that got there. In other words, by the end of 5th grade, they had finished pretty much all the 5th grade Montessori lessons, and they were ready for this stuff. This is 6th grade curriculum.
Okay.
Squaring, square root, cubing, cube root makes up the 6th grade curriculum. All right. So I had a little less than half get there. That was the year before. Last year, out of about 10 6th graders, I had 5 get there. So look, there might be years where you don't get anybody to get there, or they get there towards the end of the year and they only get through squaring, and that's fine. All right. If they're moving on to your own middle school, hopefully when you conference with the middle school teachers, you can say, hey, this child has not finished the 6th grade math curriculum. Before we move them to pre-algebra, which is the next step, it'd be really great if they could finish this. And hopefully your middle school teacher will be open to that. We do that. I do that in my school. If I have kids that are coming in that did not finish the 6th grade curriculum, even though I don't have these materials in my classroom, I go to upper elementary and I borrow the materials and I take those kids as a group, so some of the kids that have finished this curriculum move on to pre-algebra. The kids that haven't finish the 6th grade curriculum. I may not bring them all the way to cube root of trinomials or quadrinomials, which is in the album. I may not bring them that far. I may only bring them to, maybe I'll do square root of binomials like we're doing right now, and move on to cubing. So I would skip square roots of trinomials. I would finish with square root of binomials, move them on to cubing. I would do cubing of binomials maybe not trinomials, and then try to do a little bit of cube root. Okay.
So I feel like that's just from my experience here. I feel like pre-algebra in Florida is typically 8th grade, and algebra is 9th grade. So
Yeah, that is the normal, the standard. You know, I always tell parents that Algebra 1 is taught in 9th grade. If you're taking Algebra 1 in 8th grade, then you have an advanced student. They're ahead of the game. So we, you know, again, in the spirit of following the child, if I have children that have finished the 6th grade curriculum and I test them when they come into middle school, our middle school starts at 7th grade. If they come in and they show that they are ready for pre-algebra, I put them in pre-algebra in 7th grade, and we do Algebra 1 in 8th grade. I actually have a group of 3 students this year that were 7th graders who finished Algebra 1, and I will be doing geometry with them next year, high school geometry. Yeah. But these are exceptional mathematical thinkers. Okay.
So one more question: when you're doing this notation, should the children already know their perfect squares by heart, like 5 squared is 24 squared?
They should. If they don't, you can just go ahead and give them, you know, have them pull out their chart or write them out in their book and just have them in front of it. But by now, they've done so much work with squaring that they really should know that.
Okay. Thank you.
Other questions? All right, I have one more lesson that I want to give you before we break for practice. And that is, we're going to do the original problem of the square root of 625 with notation. And you know what? Maybe we can just do it right here. Let's see if you guys are okay with this and you don't balk. If you're not okay, we'll do it. Okay, I don't have a problem doing it. But since we just did it, we might be able to just walk through it. All right. So as a follow-up, I would have the children do this presentation we just did and write out the whole thing in their notebooks. And would I have them practice? Let me just see. They've already practiced square root of non-perfect squares without the notation. So I would not have them do it again with the notation. I would, after this lesson that we just did, I would move on to doing an example with them of a square root of a perfect square, like 625, with notation, so that they see the notation twice. They see it once when you have to go back and change it. They see it again when you don't, when you have a perfect square. Some will argue that you could do this that you should do the square root of 625 with notation before you do the 615 that we just did. And I would buy that totally. The album shows it the other way, but it kind of makes sense because really in my last lesson, in this lesson here, again, I was sort of introducing, well, no, it was fine. But this notation is obviously more complicated because we have to go back and cross out and so forth. Whereas the notation for 625 is much cleaner. So there is an argument for showing this lesson first and then showing the square root of 615. Because you see, this is much, much cleaner. So let me walk through it and you guys let me know if you want to do it again from scratch. So we're taking the square root of 625. We analyze the radicand. We see that our answers are going to be in the tens and units place. Our root is going to be in the tens and unit place. What is the largest square we can make out of 600? the largest square we can make is 400. We take, so right there, we know that our tens place will be 2 because the square root of 4 is 2. We subtract the 400s from the 600s to give us 200s. I'm sorry, yeah, 200s. We exchange the 200s for 10s, and we include them with the 2 10s that we had before, leaving us with 22 10s. We then build our rectangles. Let me write that down here. We then build our rectangles using up 20 of our 22. We exchange the 2 10s for units. We add those to our original 5 units. And we build our unit square. We use up 25 units of the 25, leaving us with 0, which tells us that 625 is a perfect square, and the root of it is 24. Any questions?
We have just a question. If it's not 25, I think it should be 25.
Thank you so much. Thank you. All right, at this point, we are going to practice.
So the root is 25 here.
Yes. Thank you. Yeah, that was my error. So this is the last, this is it for square root. In your album, they go on to the square root of a trinomial, which is the same concepts, just, you know, longer problems. You're going to have, let me get my trinomial guide and show you. Okay. So here's my trinomial guide. Okay, so here is my binomial guide that we've been working with. We have 2 perfect squares, 2 equal rectangles. When we do the square root of a trinomial, as we saw before when we did the work with the volume, with the cubing materials, a trinomial will have 3 perfect squares and 3 sets of equal rectangles. So you would, again, you'd start building here, and then you would build these rectangles, and then you would build this perfect square to give you the binomial, or the first part of the trinomial. Then you would build this rectangle, and this rectangle, this rectangle, and this rectangle, and finally the units. All right. I'm not going to go through that.
Okay, so here we are starting from the tens. Yeah,
You're starting from here.
from the tens.
This is actually 10,000.
10,000. Okay.
It's 100 times 100. All right. So what I want to do before I let you go is I want to give you the problems I want you to practice on. And the reason I do that is more for me than for you. I don't want to have to think about problems that I haven't worked out in the past, because my brain is kind of mush after presenting. So I want to make sure that if you have questions, I have the answers. So you know how we always say we set up our children for success? Well, I'm going to set myself up for success. All right, so let me go back to sharing my screen. I'm going to write down the problems I'd like you to practice on. And okay. So, square root of perfect squares. And I would like you at this point to just do them all with notation. Just go ahead and do it with the notation so you get to practice both at the same time. All right, so I want you to do, and you can choose, just do one of each. Either 1024 or 2601. These numbers you'd never guess that they're perfect squares, but they are. And I have one more you can try. 1849. If you don't have the materials, just do it on graph paper. All right. Okay. So that's the square root of perfect squares. And then square root of non-perfect squares. In other words, you're going to have a remainder. Okay, with a remainder, we do, sec.
Monica,
Yes.
are we really going to find out that an odd number can make a perfect square?
Yep.
Okay.
Pretty wild. Well, I don't seem to have any pre-made ones here for the remainder one, so I'll just give you a bunch and we'll figure it out together. Okay, so practice problems for non-perfect squares, 789, 677, and 530. So choose one of these to do on your own. Let's say a half hour, which will bring us to, let's see, it's 40 after the hour, will bring us to 10 after the hour. All right, any questions? Okay, I'm gonna leave this up here, so, well, you have it anyway, but maybe I should, would it be better if I left up the actual layout? Would that help better than this? Because this you can get to. This you can get to on your Google Classroom. So I think actually I might just leave this up.
The layout would be better.
Yeah, that's what I thought too. All right. Okay. And let me put this so you can see it in case you don't have it. It's not showing up very well because of, does this work better here? I guess that's a little better. Yeah, I think that's pretty good. All right, guys, I'm going to mute myself, but if you have questions, give a shout out. I'll check in every few minutes. Any final questions? We're good? Okay, I'll see you at 10 minutes after the hour. Actually, let's make it 15 minutes after the hour. All right? Okay, good luck.